Okay guys, today I'm working on an iPhone 6 Plus that came in with no power at all. Upon inspection of the internals of the phone, we determined that, it's perfect. There's no corrosion, no visible, I guess, traces of previous repairs, nothing. Absolutely clean and perfect phone, yet it doesn't turn on. So what we do in cases like that, the first thing that we check is the main power rail of the phone is PP VCC main, because that usually is the one that shorts. One of the capacitors on this line can short randomly. So here I pulled the ZXW tool for you, and here's the PP-VCC main. So all the red dots you see on both sides of the motherboard are actually the spots where we can probe the PP-VCC main. And the first test I do usually is just see the resistance of that line relative to the ground. Grab our multimeter, set it to resistance mode. I decided to try it on this capacitor. That's the one that's exposed, to be reachable without removing any of the shielding. Because, for example, these guys, or those, or even these, you need to remove the protective cover. For this one, right next to the Wi-Fi chip, this capacitor is just there for you to probe it. You can either measure, put your ground probe to the ground right here, for example, and then the red probe goes here in the resistance mode, and you should see, well, basically it should be more than 0.6 ohms. Because if it is 0.06, I'm sorry, 0.6 or 0.8, 0.9, that's like short, dead short. And in this case, it can be either of these components that is highlighted. They can be bad, or multiple of them. It doesn't necessarily that, if you probe it on this capacitor, then this capacitor is bad. Basically, all these components can be causing the short to the ground. And the trick is, as always, is to find that thing the quickest way possible. And today I'm going to try to demonstrate just how to do that quickly. Bypassing a lot of time wasting things like removing these components one at a time, because you can't really know exactly. Nothing is corroded, nothing it looks out of spec. It just all look perfect, and you want to do it quickly, but yet you don't know where to start, because there are these things. These are probably not caps. Usually it's the caps. So there's like a dozen caps on this line, and you can just go removing all of them, hoping that you'll get, eventually you will get the bad one, but there are means to do it faster. So let's just get down to it. So I'm gonna measure my resistance right here, and it's gonna be ground because I already tried it before. But for demonstration purposes, this one is the best because you will see those a lot. And if you look at the meter right now, okay, let me switch to the microscope camera. Okay, here's this cap. Here's my ground probe. Putting it on the ground plane, and I'm putting the red probe onto the PP-VCC main. And what do I get? Get 0.5, 0.8, 0.7, meaning that line is bad. And now here's what I do. I have this tool that you've seen on my previous videos. It's called Flir, and this is a thermal camera, which is super handy in situations just like that. Finding shorts is so easy with this camera. All you do is you just turn it on. Camera is right here. It's like a little attachment to your camera. Oh, let me. You see, it has a little case, and then there's this kind of like a battery pack case, but it has a few cameras here and a little reset button. It goes directly to the phone, and you can charge it via mini USB. This is for iPhone 5 or 5S. There are ones available more like universal. It's a little attachment that goes through the same port to any phones, any iPhone pretty much. And you just install the Flir app, start it up, and then point to where you want to look for any hot areas or cold areas or anything in between, and even meters the temperature for you. So, but for now, I'm gonna do some preparations. Okay, so here's our cap. So we need to find the best spot to solder some kind of wire onto this line so that we can connect the power supply and feed some current into the line. So I usually do it on this cap, and yeah, it's probably not the best option, but that's the quickest one for sure. So I get this, it's a pretty thin, like 0.1 like millimeter jumper wire. Yeah, right here. I'm gonna solder that to this edge. You know, you make sure you don't solder it to the ground portion, but to the actual main line. Okay, let's get a little bit of and now I'm gonna cut the wire. Don't leave it too short. I'm cutting it kind of longer. One is gonna be on the ground and one is gonna be on that cable, on that wire, on that line that I just soldered. So I will just twist it a little bit. Just so I get a little thicker wire, because those little grips don't grip very well if it's just a bare line. So another good thing to try here is to also solder that area of the wire, like put some solder metal onto it. Okay, so now that one is done, I'm just gonna double check the resistance, make sure that we are connected to the right spot, and I'm just putting again my ground probe to the ground, and I'm checking it on this wire, and what do I get? 0.06, correct. So now I am hoping that the problem is going to be under this shielding. So I will remove it, because now I need to expose as much of the smaller components as possible, because I want to be able to see which one is bad and pinpoint, remove it, and replace it. Or at least remove it, because this is for data recovery. Sometimes you remove a cap and you don't really need to replace it with anything if you only need the phone to work for a little bit. So now you need a power supply to complete the job. I'm using as I mentioned before, a very simple one, just Chinese DC power supply 302D. Here you adjust the voltage. It has the fine adjustment and coarse adjustment, like basically general, and then you can fine tune it with this knob. Same for current. So the current is set to max, and you can put like 3 volts or something to begin with. So you see right now it's not showing anything because there's no, obviously the current is not going anywhere. But as soon as I connect it to the short, usually it would be like over 1 amp or close to 1 amp, sometimes 2 amps on different logic boards. Sometimes on Macs I think it would be close to 2 amps if it's a dead short like that. So you will see that and all that current goes to that shorted component, and that's when you pull your Flir camera and you point it to the board in question, and like 9 out of 10 times it will pinpoint directly the shorted component. Again, don't get me wrong, it's not like the ultimate tool. Sometimes the shorts are a little more difficult to pinpoint than just this, but that probably will be in a future video. But for now, I'm trying to cover the most common, the simplest short that occurs across any types of electronics. But since we're working with Apple, so I'm showing it on Apple's example. Okay, so let's get back to our work area. Here's our logic board, and here are our leads, the negative and the positive. Okay, I'm connecting the negative to the ground, whichever one you want. I will probably connect it a little further from the positive, so gotta have a solid connection. And okay, and so now I'm connecting the lead. See, it's connected. The voltage dropped a little bit. It was 3, now it's 2.9, and it's actually showing 1.44 amps of current that's being drawn right now. So that's definitely going into that hopefully really visible capacitor that I will just quickly remove right now and show you that the phone turns on immediately. Let's see. Try and turn it on. Right now I'm doing this switch toggle on and off. Okay, so we get the power, and let me adjust this camera a little bit. Actually, let me show you the power supply. So you see that's what it shows on the current side, 144, voltage 2.9, and so you see, plug the lead. Actually, it's 2.9 still, so okay. Usually voltage drops too, but since I put the current so high, maybe that's why the voltage is not affected. So that's where our current is. And let me point to the actual phone. I'm sorry, the logic board. Okay, so here's the board. It's still connected to the current. And let's hover the camera above our phone question. Let me enable the temperature. Okay, I see 17 degrees. It's a little hard to see. 13. Yeah, you see I'm just pointing. Okay, so you see this line is getting really hot. You can see that it's burning hot. I mean, not burning, but it's hotter than most of the surrounding area. So all I'm trying to spot is a definite problematic area. That would be like a yellow bright dot, and temperature would be higher in that dot than anywhere else. So this is unlikely. Yeah, unfortunately, I didn't spot anything on this side. I don't think it's gonna be on this side in the connectors area, although let's try. Yeah, to be honest, the latest software update or the latest update of this app, the Flir app, made it a little less snappy. It's like everything is so slow now. I think I'm gonna get the newer one because yeah, it was much better. Now it's a little bit like it's lagging and it's a little harder to read. So yeah, I don't see anything, any components that are exposed that will have a definite short. Oh, that would be like hotter than things around. Yeah, you see that wire is like 24 Celsius versus the board is 16, 19. Okay, so basically I'll have to remove the shields now from the phone. I'll should either do all of them or one at a time and then redo the same thing, but I think I'll probably do the whole thing at once, remove all the shielding, and then redo the test once the board is cooled again. Okay, I actually removed the shielding, but I think that wasn't quite necessary. All I did instead to kind of intensify the effect is I added a little bit of more voltage to on the power supply so that we get a little more current going through the bed line. This way I get a little better thermal effect. So if the image is a little shifted, but yeah, let me point it to the camera as much as possible. Let me turn off the microscope light for a second. So here I am going over that power management chip, and if you see, there's a little bit of a problem that we can spot somewhere over here. And again, this tool is not like mega precise, super precise. Another thing that we can do is, you see I'm pointing at this spot. Turn the power supply off. Oh. You see it disappears. There's a little bit of glare in the bottom. Don't pay attention. You see now the power supply is off. And we still get that. Yeah, this is with the new app. It didn't do this stuff before. It was a little more precise. Now it's just all these glares and little extra yellow spots that are reflected from every metal surface there, which is a bit distracting. But let's try to use what we have and see if we can get the result. So I power this power supply and we get the so it's somewhere right here in the center. Oh, okay, now I'm gonna just point the like a plastic tool somewhere around that area. Okay, that is going to be that is going to be either this cap or possibly this, but I'm almost positive it's going to be this one in the, like, not the one all the way at the edge, but the second one. And if we switch to the schematics, we'll see that, okay, so this is the area, and you see this is our oh yeah, this is our where's the pointer? Okay, the pointer disappeared, but basically it's, you see where it's blinking? Oh yeah, this capacitor, that's what we're looking for. So let's remove that, this one right here. Let's remove that and see if we still have the short. Okay, that should be, that should be this one. Okay. And I'm using the Hako FR810 Airflow 1, and I'm putting it to 350. I hope that wasn't the problem. No. Okay. It was just a little bowl of solder that I saw that could have been the reason. So technically it can still be either this, or that. They're all on the same line. Those ones, the second row, if you remember from the schematics, they were not related to this line. So for now, let's just remove the one that was in the, pretty much in the center of that yellow spot, or like bright spot on the camera, and see if we get the short fixed. Okay. So let's do the okay, if you see, already we get the 100 and something kilo ohms. So now let's just measure the actual cap. I like measuring the caps too, just to kind of confirm 200% that what I've done was the problem. Here's our cap in question. Measuring that, and then get up. Okay, this thing, if you see, it's 0.05. So this is the V2, all right? Now it's up to you. If you want, if you need a quick fix, get the data out. You can just leave it like that. If you want to do a good one, you can replace that cap with a donor one or with a new one, whichever you have, and be done with it. For the purpose of this video, we'll probably I'm not gonna replace it, although I will put the shields back and assemble the phone. Okay, now that the shields have been put on, I'm gonna do a quick test in the phone, in the casing, and see if we really did a successful repair. I have not powered it on yet, so it's gonna be done on camera. We'll see if I'm lucky. Okay, nothing happens when I press the power button. So let's see if the charging. And if you see, oh, okay, well, that's definitely better than nothing, right? Here we have the passcode for it. Let me try and see if the touch works so that we can extract the data. And the rest, I pretty much don't care. If there is a bad camera, if there is buttons don't work, Touch ID doesn't work, I can care less about that. All I care is that I can touch it, touch the screen to get the password. The computer should recognize it, but I already hear that it's recognized by the computer. Okay, so we see some customers' information. And obviously, if you see, oh, things are working. You see, I'm kind of showing it to you at an angle because it's a customer device. So, but basically, the result is obvious. It was just a randomly shorted capacitor that. Happens a lot on these. So if you see 100% perfect looking phone, logic board, no liquid damage, no previous attempt to repair, none of that. If it looks like brand new and yet it still doesn't turn on, the first thing you want to check is measure resistance on the PP VCC main, and in most cases that's where the short is going to be. And then you can use multiple options, multiple techniques to discover that short, but the one that we explained in this video, using the thermal imager, is the fastest. It's a little, when I'm recording a video, it looks a little more tedious, but when you do it without all these setups and preparations and explaining, then it can be done within like 30 minutes and you'd be completely done with the phone. And sometimes if you do it the old way, ripping all those caps, it can take quite a bit of time, and every time you need to measure the resistance, and God knows what you can overheat by just removing and replacing all those caps. So definitely, if you're in the business, definitely have a look at this thing. And I'm not affiliated with the company. I'm just being me, and I'm sharing what I've discovered over the years and what tools I've learned to use. Feel free to suggest something. If you have any corrections or any suggestions about anything in this or any other videos, please give this video a thumbs up. Subscribe to our channel if you haven't done so, because there's definitely going to be more tricks and tips on the repairs of Apple products coming up. Thank you. Bye.